Hi everyone. Today we're going to talk about rational equations. And our goal is to solve for a variable that is in either the numerator, denominator, or both of the fractional part of an equation. If at any time we go too fast, feel free to stop or pause and copy down what you need to. Otherwise, replay it, but make sure you're paying attention to this as we're going through this. This should be review for you, but if it's not, please make sure you're asking questions on that haiku section. So a rational equation are equations that have one or more rational expression. And we looked at rational expressions in the last chapter as we graphed them. We have something called extraneous solutions, and those are answers determined algebraically that are not actual solutions. And graphically, we saw those when we found a solution algebraically, except when we plugged it in, it didn't work. And graphically, when it didn't work, it was either an asymptote or it was a hole. So let's take a look at a basic example. We've got 8x minus 2 times the quantity of 5x minus 3 equals 7 times the quantity of x plus 1. So automatically we know we have to distribute. So distribute a negative 2. So negative 10x plus 6 equals, on the right hand side we're distributing a positive 7, 7x plus 7. We want to get the variables on one side and we can combine our like terms. So I'm going to subtract or add 2x here. So 6 equals 9x plus 7. Start to get the x by itself, subtract 7 from both sides. So negative 1 equals 9x, and divide by 9. And we talked about those extraneous solutions, and that happens when you check it and it does not work. It's not a viable solution. So we need to make sure that we are checking our answers. So we're going to take the time to check our answers. So we've got 8 times negative 1/9 minus 2 times the quantity of 5 times negative 1/9 minus 3 equals 7 times the quantity of negative 1/9 plus 1. So negative 8/9, because 8's 8 over 1, when we're multiplying fractions, we go straight across, minus 2 times the quantity of negative 5/9 minus, I'm going to write a common denominator here right away. So this is 3 over 1, so I'm going to multiply by 9 to the numerator and denominator. 27/9 equals 7 times, get your common denominator, so 9 over 9. 9 minus 1 gives me 8/9. So negative 8/9 minus 2 times the quantity of negative 32/9 equals 56/9. So negative 8/9, negative times the negative becomes a positive 64/9. And this does indeed work out. 56/9 equals 56/9. All right. So x equals negative 1/9 is our answer. So here's an example of a rational equation. We've got a rational expression 5x over 3 and a rational expression 3x plus 2. So when we're looking to do this, a step that we learned last year was to get rid of the denominators in each of the fractions. Now I don't want to do it for one part and have to go through. I want to do it all at once. So what I'm looking for is that least common denominator. I want to find the least common denominator of 3, 1, and 2, so my least common denominator is 6. I want to multiply my entire equation by the least common denominator of 6. I personally find it difficult to remember to distribute the 6, so I'm going to write it each individual part times the least common denominator. To me, this helps me keep that least common denominator out there and able to be seen and easily reduced for each of the parts. So we've got 10x plus 42, and I want to distribute that 3. So 9x plus 3. Get our x's on one side. And subtract 42. So x equals negative 39. When I double check by putting that back in my equation, there's nothing I have to worry about too much because my denominator does not contain a variable. So this is a quick substitution, plugging in negative 39 for x and verifying that this works. So we've got negative 65 thirds because I can reduce 1, and that becomes 13, plus 7. Oops, not thirds, just negative 65. And that equals negative 117 plus 1 over 2. So I get negative 58 equals negative 116 over 2. So negative 58 equals negative 58. That checks off, so x is negative 39. Our third example that we're going to take a look at is a little bit more complicated. Now I've got the quantity of x squared minus 1. I've got x over 1. And I've got x squared plus x plus 2 over x plus 1. When I'm looking at my least common denominator, I'm looking for factors. X plus 1 is a factor. That's got to be part of my least common denominator. I want to factor this other denominator, x squared minus 1. That's x plus 1, x minus 1. These both have an x plus 1, and I already have that in my least common denominator. So the only other part that I need to add is x minus 1. So I need to multiply x plus 1 times x minus 1 to each one of these rational expressions. And then I want to reduce each of them. X plus 1 crosses off. X squared, x plus 1, x minus 1 crosses off. So if I'm looking at this, I'm left with x squared minus 5 plus, these two can be put back together, factor or multiply them together, so I get the quantity of x squared minus 1 times x. So I have x cubed minus x, and that equals x minus 1 times the quantity of x squared plus x plus 2. So I want to distribute this. I want to multiply everything in this quantity by x, and I also want to multiply everything by a negative 1. So x cubed plus x squared plus 2x minus x squared minus x minus 2. X squared and negative x squared cancel off, so I can reduce those. So I've got x squared minus 5 plus x cubed minus x equals x cubed plus x minus 2. I want to get the x's on one side, so I'm going to subtract x cubed and subtract x cubed, subtract x. My x cubes completely disappear, so I have x squared. I'm going to rewrite it in descending order. Minus 2x minus 5 equals negative 2. Well, I now want to get everything to 0 because I can see this is a quadratic. And if it's a quadratic, I want to get everything on one side. So it's in the quadratic equation form. So x squared minus 2x minus 3 equals 0. And I always want to check to see if things are factorable, because that's the easiest way to solve. So negative 3 and a positive 1 will work. factor to x minus 3 times the quantity of x plus 1 equals 0. Zero product property rule says that if two things multiply to equal 0, either the first one equals 0, the second one equals 0, or both equal 0. Add 3 to both sides, so x could be 3, and x can be negative 1. So when I plug this back into my original equation, I want to do that for each of these. 3 and 1. 3 and negative 1. So if I plug in 3 squared minus 5 over 3 squared minus 1 plus 3, checking to see if that equals 3 squared plus 3 plus 2, fitting that in, over 3 plus 1. This side will be 9 minus 5, so 4 over 8, which is a half. 1/2 plus 3 is 7/2. 9 squared, or 3 squared is 9, plus 3 plus 2 gives me 14 over 4, which reduces to 7/2. So that works. X equals 3 is a solution. When I plug in negative 1 squared minus 5 over negative 1 squared minus 1, I can stop right there. Because in my denominator, I get 1 minus 1, which equals 0. We know we cannot have anything over 0. So x minus 1 is an extraneous solution, which we need to cross off.